Before moving to Harvard in 2018, he taught at Princeton for 15 years, and he specializes in the development of statistical methods and machine learning algorithms and their applications to social science. His areas of expertise include causal inference, computational social science, and survey methodology. Outside of Harvard, Imai served as president of the Society of Political Methodology from 2017 to 2019. So I'll let you go ahead. Yeah.
Well, thanks for...
and he's also a BERS alumni, so thanks for coming back. He was at the original BERS workshop.
Yeah, well, thanks for organizing the conference. And yeah, it was 2 years ago. That's awesome. I'm on my way from Tokyo. I arrived yesterday and still not sure what time this is. But I'm glad I came here at the right time. Yeah, so this is really, I think, the project that fits the goal of the conference and this group, where I'm trying to sort of bring from evaluation to implementation with my longtime collaborator, Jim Greiner, who is at the Harvard Law School. We've been working on this for, 7, 8 years. It's been a long time, but we made some progress, and I think maybe we're getting closer to implementing something in the real world. We've been focusing mostly on evaluation so far. Okay, so that's sort of the broader framework. Yeah, so I think I've been interested in this sort of algorithm-assisted human decision-making. It's all everywhere. In particular, I've been working on the criminal justice space where the Jim Greiner, who has very strong expertise and field partners. So here, we are interested in risk assessment instruments or risk scores that we often talk about. And I think people use this phrase to mean different things, but when you look at a specific implementation of this, it's often a prediction of the likelihood of some undesired outcome without intervention. So that's sort of trying to figure out what would happen if you don't intervene at all. How bad, what kind of bad outcome could happen? So if there is a high risk, that is the likelihood is high, then this type of algorithm would recommend some intervention. Yeah, so there's examples of this is everywhere, medicine and criminal justice system. And I think there's also a methodological literature in CS and statistics and relevant areas. I think Amanda will be here sometime. Back in 2020, there's a nice paper, and Imai, who probably will appear at some point, Imai and I worked with Jim and some others, trying to look at, from the methodological point of view, what this type of risk score means. Okay, and here I think the main methodological problem is the selective labels problem, where when you're evaluating, people are making decisions already, so and those decisions are not random, so you have to sort of account for the fact that the decisions are selective, and you only get to see the outcome when the decision maker decided not to intervene. Okay. So the next step we are thinking about is very simple, and it's probably comes naturally to people who've been working on the causal inferences. This seems to all miss what would happen if the decision makers does intervene. So the prediction is really focused on what would happen without intervention and doesn't consider what would happen if you intervene. Okay. So I think it's easy probably to argue that the effective decision making requires consideration of how the decision affects the outcome, not just a prediction of outcome without intervention. So we call this triage score, which we try to incorporate the counterfactual outcomes under alternative decisions. Okay. So where does the word triage come from? Actually, I blame Jim Greiner. I'm telling you, and he's maybe watching. It comes from the French word of sort, and I guess it goes back to Napoleon's military surgeon, who decided to work on people who have worse wounds rather than those who first come and first serve. This system wasn't really fully counterfactual in the sense that we're going to talk about, but I think that's sort of the motivation of our new framework that we are thinking about. So we're trying to sort of focus on who benefit most to maximize survival, given some resource constraints, instead of just sort of focusing on the prediction without intervention. Okay. So at the core, the triage score is really just a statistical decision theoretic framework. So as I think from going from just evaluation to implementation, I'm thinking more in the framework of sort of decision theoretic framework. And standard decision theory, as you know, start by specifying a utility for each decision and its consequence. So you try to formalize what you're trying to maximize. We are focusing on the counterfactual decision theory, which incorporates the counterfactual outcomes and the alternative decisions when specifying each utility. So we're trying to sort of incorporate what might happen if you make a different decision when you specify the utility function. Okay? So there's actually quite a bit of literature recently focused on this type of counterfactual utilities, and I've been interested in this area for the last several years, and it allows you to sort of incorporate the nuanced notions of things like regret or difficulty or do no harm principle or certain type of fairness principles. So I've worked with some of my collaborators, and there are many other works that's out there that focus on this type of framework. Okay. There are sort of two types of comparisons that we look at. One is the risk versus triage score, but there's also the standard versus counterfactual utilities that are quite different in terms of how you implement it, how to do statistics on it. So eventually I want to sort of answer the questions of, do algorithmic recommendations help humans make better decisions? When should human decision makers be ignoring or following recommendations? And what is the better score that we can develop that the decision makers can use if the policymakers are able to put together the expected utilities? So today I don't really have a material, but we have some field partners now that we'll be working with, where we hopefully allowed to develop a better triage score to help them improve their decision making. So this involves sort of working with the field partners to elicit their utilities, trying to formalize and put them in the framework that we've developed, and try to implement that whole thing in the real world. So we are sort of at the beginning of that process, where we have some agreements with field partners, and God knows how long it takes, but we hope to implement some of these ideas in the real world to improve the outcome. Okay. So that's sort of where we are. So today I want to just briefly talk about what this triage score that we are thinking about look like, and I'd love to have suggestions and criticism so that we don't mess up things when we implement these things in the real world. Okay, so empirical application we're working on is public safety assessment, or PSA. So for those of you who don't know, it's basically a recommendation judge receives as to whether to release an arrestee in the pretrial period, and it also involves under what conditions that someone should be released. Okay. For today, I'll just keep it simple. In the paper, it's a little bit more complicated. The decision itself is not just a binary. Okay. So PSA is just is an algorithmic recommendation to judges. Inputs are age and criminal history, essentially, and no gender or race is directly used, although those are correlated. So you see the actual risk scores, they're correlated with gender and race. outputs are risk factors, and that also recommendation based on those risk factors. It's actually widely used. This particular system across more than 25 states use this system. Okay, so PSA is a risk score prediction under release. So what would happen if a judge releases someone? So the outcome they are interested in is these things: failure to appear, new criminal activity, new violent criminal activity. But it's really like, what would happen if you release someone before trial? Is there going to be a new criminal activity or other undesirable outcomes? Okay. So this is how the particular jurisdiction that I'm going to talk about is used. This is basically the recommendation that judge receives. Okay. So there's like 3 scores based on those 3 outcomes, and these are the inputs, and there's a recommendation at the end. Okay. So it's actually like judge sees all the inputs. It's really the weighted average of these is given as a score, and that's the new information that judge receives. Okay, and does a judge follow PSA? Okay, so we've done a bunch of RCTs across the U.S., several jurisdictions, not necessarily representative, but places where we're interested in evaluation. By the way, we made the Wisconsin data publicly available, so you can just download them and analyze for your own project. This one is Utah, this second jurisdiction we worked with. We have 7,000 about arrest cases, and we basically randomize the provision of PSA. So for some cases, the judge sees the report that I showed you. The other cases, the judge doesn't. Yeah. So you can ask, like, does the judge follow PSA? So on the top, this is in the control group where the judge doesn't. Yeah.
Does the judge see all the covariates, or
yeah?
Okay, but not the.
The covariates are in the report.
In the control,
yeah.
He sees.
Oh, in the control, yes, they have access to those covariates.
It's just the weighted average.
Yeah.
And how many judges?
1.
Oh, okay.
For this particular one. Yeah. We have several jurisdictions, but yeah, it's randomized across cases as opposed to across judges. Yeah. It's hard to increase the number of judges in the experiment, but I think the obvious top point is really important, because whether they are influenced by the recommendation vary greatly, like huge amount across individual judges, and even among the small number of judges we worked with. So that already shows this, maybe the uniform score given to every single judge is probably not a good idea. Like each judge deals with this type of information differently. But yeah.
Like, is there policy in, this is Dane County?
This is in Utah. I can't tell you.
Oh, okay, sorry.
I can't tell you which county it is yet.
But like, do they have any sort of policy requirement to like map a particular risk score to like high risk, low risk, like a decision-making framework, the DMF?
Yeah, they do have.
Okay,
yeah, they do have that. Yeah.
Okay.
So
this is not just pure discretion or something. It's
right.
directly guided by.
Yeah, that's right. That's right. Yeah, it's literally what they've been implementing.
Okay.
Yeah. Okay. So if you look at this, and the bottom is a treatment group. So this is when the judge sees the PSA, and you can see that in this particular case, the judge tends to be harsher than the recommendation. But so there's a huge number of cases where 50% of cases judge actually makes a cash bail decision when the PSA says you can release that person. Okay, but that number gets reduced when the PSA is shown. So there is a impact on the judge's decision. Yeah, so the next step is to think about, is this inference, is it in the right direction in certain sense? And can we also come up with a better score? So those are the sort of steps that we are interested in. Okay. Yeah, so let me just tell you briefly about the statistical decision theoretic framework. just with a simple case, binary decision and binary outcome. Okay? So let's make the D star a decision made by some decision maker. So it could be a decision maker, could be a human, or could be a human with aid, or could be just the algorithm makes the decisions in itself. Okay? So D star, if cache bail decision is made, is equal to 1, 0 otherwise. Okay? So if the judge or some decision maker decides to release the RST. Okay. Y is going to be outcome, the binary outcome, undesirable outcome. So in this case, failure to appear, new criminal activity, and so on. And we think about the potential outcome. So decision affects the outcome. So the outcome is a function of the decision. Yeah. Okay. Yeah, so one thing you can think about is once you have this simple setting, what's called in causal inference literature principal strata. So it's a joint distribution of these potential outcomes. So you can think about if both y of 0 and y of 1 is 0, then these are sort of safe RST in the sense that no new crime will be committed under either decision. So it doesn't really matter what the decisions is. Either case, there's no new criminal activity, for example. Okay? And there's also preventable case and maybe the risky case, regardless of what the decision is made, the new crime would occur. Okay? Because cache bail doesn't necessarily mean that the arrestee will be detained. Arrestee may be able to pay the cache bail, and maybe cache bail has a negative consequence. Like if you have to come up with money that may lead to the undesirable outcome to some extent. Of course, like we get to only observe one of these two potential outcomes, so we can't actually classify each individual into these 4 different groups. Okay? So one way to think about it is like a risk score is only considers y of 0. So what would happen to the outcome if the no intervention is made, that is released by the judge, and triage score considers both of these outcomes. Under the cache bail decision and also release decision, what are the outcome might be. Okay, so you can put this in the utility function framework. We have a lot of sort of notation here, but it's basically the standard utility. This black little thing is the standard utility under decision. So what's your utility if you make a decision D and the outcome that follows by that decision. Okay? And there's also potentially the counterfactual utility under alternative decisions. So what you might consider when you evaluate in a particular decision, what might happen if you've made a different decision. Right? And so here, for example, in the backlash case, and if you make a cache bail decision, then you incur the utility, because it's a backlash case, the negative outcome happens, so you incur utility with cache bail decision and the crime happening. And then you also have this maybe a regret type of notion where if you have released, the crime wouldn't have happened in this particular backlash case. Okay, so those are sort of so this is a counterfactual utility, whereas this one is the standard utility function. So this is sort of the general framework you can imagine thinking about doing.
Just to clarify,
Yeah.
in the real world, someone borrows money to pay their cash bail and then goes out to commit a crime to pay back
Yeah,
the
so
debt they incurred to pay their cash bail.
yeah, so this is a sort of the important discussion we'll have with the field partners, because in the criminal justice system, the cost might occur to the public in terms of crime happening, but also if for the arrestee, if they have to come up with a cash bail, that's a cost to that person as well. Okay, so yeah. So the question is whether we can work with the field partners and think about these concepts in a certain systematic way, and then reflect that in our scores that we will develop. We don't know whether we can do that yet, but that's the goal. Yes?
Is there other utilities besides just having the crime or not, like suffering of the defendant?
Yeah. So there's definitely, right now I'm sort of simplifying into sort of binary outcome, binary decision, but these nuances will probably happen once we start, having the conversation with the field partners and figuring out exactly what that system looks like. Yeah, so these are, very important. Yeah.
So should you think of the counterfactual utility as like an opportunity cost correction?
Yeah, so the one is like the notion that if you could have released someone and no undesirable outcome would have happened, then you should have released, right? Even though you can detain everybody, and maybe in that setting, the very few crime would happen. So that's sort of the thing that we are trying to look at. And I think in the case of criminal justice system, as someone mentioned already, the cost notion is not one-sided. There's a people who are arrested, and there's a cost to them, but there's also the potential cost to society. So the balance these two, we've been arguing that require some notion of counterfactual utility. But some people disagree, like strongly disagree. So I want to also mention that as well. Anything counterfactual, people are allergic to things. So, and it's hard to sort of reconcile those disagreements, but yeah. Okay. Let me just go quickly. So on the risk score, you combine these two groups because you only care about y of 0. So you combine these two groups into one, and same thing as here. It's kind of interesting because these utilities on the risk score contains both standard utility. So on the left column is a standard utility. This is the decision followed by the decision you make, and then followed by the outcome. Whereas on the right, it's a counterfactual utility. Decision you make is based on what would have happened if you didn't intervene. Okay? But it's actually a special case of the triage score. So you can think of the triage score as a sort of more general framework, accommodates different type of utility structures. Okay. When did we start?
Oh, you have 15?
Okay. So we've done some methodological work. As you might expect, expected counterfactual utility is generally unidentifiable because it involves these two potential outcomes that are not directly observable at the same time. So you think about the general case, you have this joint distribution of these potential outcomes that are not identifiable. Okay. So many people, like Julia Pearl's group and also some of our earlier work, looked at the partial identification approach to try to develop the bounds, the sharp bounds on these expected utilities, and then, for example, maximizing the lower bound to try to come up with the best worst case scenario. Okay. One thing we realized recently is that actually we can impose a little bit more structure and then get the point identification. So additive counterfactual utility, so the utility structure I showed you earlier is actually additive in the sense that there's a standard utility and then there's a bunch of counterfactual utility. Okay. In this case, we can actually point identify from the data. So standard utility is a special case where this doesn't exist. Okay. But even if this exists, if you have it in the additive way, so there's no interaction, then you can actually identify because you can just integrate out, like changing the summation, order of summation, and marginalize the joint potential outcome distribution. Okay. So it turns out this is the necessary and sufficient condition for non-parametric identification if you want, under unconfoundedness, if you actually want to use the counterfactual utility and the point identify, as opposed to just working on the bounds, which has its own benefits and limitations. Okay, so that's sort of the, and I feel like in practice, the additivity is probably okay. Like it's already complicated. So when we talk to these things to the field partners, I think additivity is not doing much, right? Even adding the counterfactual utility, whether that's necessary or not, I think it depends on what the application is. Okay, so let me sort of talk about like how this might look like in our application. Okay. So in the application, we basically have this Aristides behavior, the outcome. A judge actually makes a decision. In the treatment group, they see the PSA, and in our work we've assumed that PSA doesn't have a direct influence on the Aristides behavior. So there's no direct arrow from R to Y. The PSA only affects the outcomes through the judge decision. Okay, we call this single-blinded treatment, and the PSA can only affect the outcomes through the decision. And because of the randomization in our study, the ZI, the assignment of the PSA, is independent of all the potential outcomes. In our case, this Utah case, is actually judge never sees the defendant. So this is a case where judge basically makes a decision based on the documents they receives alone. So it's maybe a controversial case, but it has a benefit for the analysis that we have actually all the information that judge has when the judge makes pretty much all the information that we judge has when the judge is making decisions. So we can actually assume that, I think credibly assume the decision also is unconfounded. Usually decision is not unconfounded because who knows why the judge is making certain decision. But in our Utah application, we actually have all the information the judge has when they are making the decision. So we can actually make this unconfoundedness for not just the assignment, but also for the decisions itself. Okay. Okay, so here is another piece of information the judge has affidavit of probable cause. And this is the information we have. So we can basically condition on this and assume unconfoundedness. A lot of things are reducted, but what we basically, but this information contains is there's some structured information, so type of offense. So if you look at here, it tells you the offense description, and it also tells you a statute that the prosecutor is using to charge this person. And so there's some structured information, but then there's unstructured statement of probable cause. So you can see, it might be hard to see, but it basically is sort of circumstance of arrest. So how this arrest happened, it's a description of that. Okay. So we also want to condition on this information. So one of the things that I've been doing when you have unstructured information like this is using open source LLM to get basically the internal representation. So what we've been doing is that telling the open source LLM to reproduce this text, okay, and have it reproduce this text and then take an internal representation from that LLM. So this number of, bunch of vectors are guaranteed to contain all the information that's necessary to produce that text. Okay, so it essentially gets embeddings for that specific text for free. And so we can, and it also has a nice sort of structure as an internal representation that often there's an autoregressive structure, so we can have a nice pooling strategy to get further lower dimensional vector that lets you do machine learning. Okay, so that's what we've been doing. So we use that trick to account for this piece of information as well. Okay, Yeah, so it's actually sort of nice way of getting a specific embedding for the piece of unstructured data. Okay. Yeah, and then once we have that, we do the usual policy variation learning. So this, I don't think I need to tell you much. Basically, we have this AIPW estimator for the decision and outcome models. And there's some neural networks thing going on because of this unstructured data that we need to incorporate. And you get some statistical properties. So once we develop this, we can do a hypothesis test. Like when do we prefer, for example, when we do prefer human plus PSA over human alone by using hypothesis test, given the utility function. So the goal is to work with the field partners to develop this. And then given that, we sort of help them make certain decisions, policy decisions, using this type of framework. Okay? And then try to develop optimal score, triage score. Yeah.
On the previous slide, when the unstructured text, you're just using the embedding as a covariate. You're not like asking the LLM questions or having a prompt that somehow extracts meaning from besides just the embedding.
Yeah, just the embedding, because I want the exact text, like whatever that information that's necessary to produce that text.
Wouldn't you be able to get, I mean, it seems like you might be able to get more information.
Yeah, we could probably get more information by asking a bunch of these questions, and that could be also, I guess, included in addition to just the text itself. Yeah, that's certainly true. Okay, so let me just show you some preliminary results and then I'll finish, okay? So we have to specify utility. For this is really preliminary, like it's happened like a couple weeks ago. And the actual application will be working with field partners, so this needs to be carefully thought through. For now, we are just sort of focusing on the cost. There's lots of parameters, so and the regret from the counterfactual outcome. So you incur some regret. For example, in the backlash case I talked about, you made the cash decisions, so there's a cost of making that cash decision, and then there's the cost of the fact that the crime happened after cash decision, and then there's some regret that happened because if you could have released and then no crime would have happened. Okay? So you have to specify these elements of utility function in order to apply this type of method. Okay. So all of this sort of you can think about different ways. Like you can do standard decision theory with risk score, standard decision theory with the triage score, or you can do counterfactual decision theory with the risk score or the triage score. So as you go down, it becomes more general, so it requires more parameter utility specification. So I think a lot of this is application specific, and then we are hoping to work with the field partners to figure the details out. Okay, so we done the quick sort of very preliminary analysis where there are different parameters here. So on the y-axis, we have cost of cash bail decision. This is the regret that I mentioned. If you could have released someone and no crime occurred, these are the regrets that you incur. So as you go to the right, the regrets get bigger. And this is the cost of crime followed by cash decision. Okay? And if you look at the blue box, this is the risk score system. So risk score system under this utility specification assume it sort of corresponds to the case where this is standardized to 0. So this is what you get depending on the cost of the cash decision, whether you prefer human plus PSA, which is the red. If you prefer human alone without PSA, it's green, and then the gray is the ambiguous. So in this case, what we see is that more ambiguous on the Triage score than the risk score. So the ambiguity, this is not really surprising, I guess, because the Triage score is more nuanced notion. So there are a lot of cases where statistically it's indistinguishable whether the PSA should be provided to the human or not. Okay. But the point is to sort of work with the field partners to figure out these parameter space and then try to present them with the results that what they may want to do if you specify certain utility structure. Yeah.
It seems like my understanding of this case is it would be the idea of the policy would sometimes give people the PSA and sometimes not based on the expected utility. But if a human was getting that, they might change their decision making. Like if they knew they were only getting it if it was supposed to help, they might overweight that information or underweight. So I was wondering how you think about
Yeah, no, that's right. Yeah, so that's a really good point. Yeah, so I think we could either actually withhold that information or advise not to give, not to follow the recommendation. Of course, that's a difference, so that needs to be evaluated again. But yeah, so this is sort of, yeah, I'm giving you as a illustrated example, but definitely that's right. Like once that particular system change gets in place, then the humans adjust. Yeah, so another, I think, important thing which we've worked on, I didn't have time to talk about today, but it's sort of the dynamic settings where these systems are changing in a certain way, and then we are continuing to evaluate. Yeah, so that's, yeah, although it's unclear whether we can actually implement that in practice, but it's a low resources setting. Yeah.
Did you consider maybe like temporally, because I'm assuming you randomized individual like odd even cases.
Right.
Did you consider maybe like a period in which there was no PSA, a period in which there was a PSA, and then a period in which it was like selectively?
Yeah, no, I think maybe possible, but in the court system, it's often impossible.
Oh, I see.
Yeah.
You had like a fixed experiment period.
It's just like, the person dealing with just can't deal with
Oh, I see.
all these
Got you.
complications. Yeah. But with other field partners, maybe it's possible.
Okay.
Yeah, courts, it's hard because we can't really take over the
Yeah.
system, right?
It's a judicial system.
Like you have to tell them what to do, and
Yeah.
there's a resource constraint.
Oh, so you have negative 5 minutes, I think.
Oh yeah, okay, all right. Yeah. So we can also do optimal decision rules. Yeah, okay. So let me just conclude. Yeah. So this Triage score is sort of the comprehensive decision theoretic framework to help guide the human decisions. So we apply this to the pretrial risk assessment instrument. So as I said, next step is to do this RCT with the optimal Triage score and develop it. So it's in planning and evaluate the human Triage system in different settings. Yeah, thanks.
While Hannah's setting up, we can ask Kosuke some questions.
Yeah.
Two quick things. First, when you're doing the embeddings, what's like a typical dimensionality you're pulling out?
It's like 6,000.
Okay. And then I'm trying
Which
to...
is a lot lower than essentially infinite dimensional
No,
text.
understood, but when you have 7,000 cases, that,
Yeah.
So, and then the next thing I'm trying to get my head around is, it sounds like procedurally this is kind of Kate estimation, sort of dragon net style.
Yeah, yeah.
And then at the end you tack on the utilities. Is that the way I should think about those two things working together, or?
Yeah, so we're still so there's some instability because of the small sample size, and when you do the optimal decision, because it's discrete in a situation when we do optimize over utility function. But you're trying to ask. I'm just trying to.
We can talk about that.
Yeah,
I'm trying to
yeah.
understand the mechanics of it a little bit more.
Yeah. So we are estimating basically, expected utility under different decision rules, and then try to optimize over that. Okay.
Just give me 1 moment.
Oh, no worries.
I got time to follow.
Yeah.
Okay, well, are you set up or? Yes. Okay. Hello. Okay, so I'll do a very brief introduction for Hannah. Hannah is an assistant prof at Columbia